In the previous part, we'd seen a velocity time graph in which the velocity was constant. But what if the velocity wasn't constant? How would the graph look? Here, again we have a graph with time represented on the x-axis and the velocity represented on the y-axis. The car starts from a standstill and in a second reaches a velocity of 5 meters per second. In the next second, it reaches a velocity of 10 meters per second, and then in another second, 15 meters per second, and so on. Clearly, the velocity is not constant here. But can you tell me what's constant in this particular example? Yes, it's the acceleration. The change in velocity is constant in each time period. And because the acceleration is constant, what we have here is a straight line. In the previous part of the video, we calculated the distance covered by finding the area of the shaded region. But as the velocity was constant here, the shaded area was a rectangle. And finding the area or the distance was easy as we knew the formula for the area of a rectangle. So will our method of computing the distance covered work here in this case? Yes, it will, and this is how we do it. Let us try to calculate the distance covered in the third second. So we draw lines from the start time, which is the 2-second mark, and the end time, which is the 3 seconds mark. We draw them parallel to the y-axis and draw until they meet this line. We saw previously that the area of the shaded section was equal to the distance covered. That is the same even in this example, except for the fact that we now have a mix of two shapes here, a rectangle and a triangle as well. So what we need to calculate is the area of this rectangle and the area of this triangle, and then add them to get the distance covered in the third second. Calculating this area will get us the precise answer. Let's name the rectangle ABCD and let's call this point E. The area of the rectangle will be AB times BC. And do you remember the formula for the area of a triangle? Yes, it's half base times the height. The area of the triangle will be half AD times DE. Adding these two will give us the total area. Hence, the total distance covered will equal AB times BC plus half AD times DE. Work it out and see if you get the correct answer. We should get the answer as 12.5 meters. That's the distance this car travels in the third second.